thought I'd give you just a quick example of doing one of these Fourier series so that you can see how to see another example of doing one with a piecewise defined function. So to that end, let's say we do the following function. Let's say we have one period of f of x is the piecewise defined function 2x if x is between, let me erase that, between 0 and 1, and it's equal to 2 if x is between 1 and 3. Now I'm not going to do a full-blown what the full series looks like. I'm going just to get some terms and get a graph so that you can see that this really does match this particular piecewise defined function. So again, to be able to do this, I've got to compute the integrals from 0 to 3 of f of x. I've got to do the integral from 0 to 3 of f of x times cosine of the period's 3 here instead of 2 pi, so I need to do 2 pi x over 3 times n. And I've got to do the same thing for sine. I need to compute those three integrals. Now, since we have a piecewise defined function, I'm going to need to split these integrals into two pieces. So I'm not going to write the other ones down, because you get the idea, hopefully. But since this function changes definition at 1, I need to compute two separate integrals, one from 0 to 1 and one from 1 to 3. And I would need to do the same thing for the cosine and the sine coefficients that we're going to compute. I didn't put the periods in front. Well, I'm going to worry about that at the end, just because I think it's easy. Personally, I think it's easier to put it in at the end. If you want to put your constants out in front and have those adjusted to start with, please do. But for me personally, I like to put them in at the end instead. But these are the three integrals that we need to compute. So let's pop over to GeoGebra to do that. So let's get GeoGebra opened. Here we go. Remember again, for GeoGebra, I want to select the computer algebra system, not the algebra window, because I want to just get do this in terms of n to start with, and then get the graph going. So remember our function again was 2x if x is between 0 and 1, and 2 if x is between 1 and 3. So for the first one, let's just integrate the function. So I need to integrate the function 2x on the intervals from 0 to 1, and I need to add on the integral of 1 from 1 to 3. So I get 3 for the total. All right. I need to do a similar computation for the cosine and the sine. So again, notice I've already broken it up into two pieces, so I'm going to do the same thing here. I'm going to integrate 2x times the cosine of 2 pi nx over 3. And we're going to do that from 0 to 1. And then I need to integrate just 1 times that. So I'm just going to type in cosine of 2 pi nx over 3. And that is from 1 to 3. So that's what my command should look like when I enter it. So we'll hit enter, and I get that particular formulation. Again, if we were going to write down a nice formula for the Fourier series, I would see if there's pieces that we could eliminate. For example, right here in the first term, I've got multiples of 2 pi that I'm taking the sine of, so that's always going to be 0. So I could simplify that term a little bit. I'm not interested in doing that for this particular example. I just want to get some terms down for a Fourier series so that I can see a graph of what we should be seeing as an approximation to the function that we have. All right, so I want to do the same thing now for sine. So I'll type in the integral of 2x sine of 2 pi nx over 3. And again, that's from 0 to 1. And I want to add on the integral. Again, this will be 1 times the sine of 2 pi nx and divided by 3, and that's going to go from 1 to 3. This is what the command should look like in this case. Hit enter. Again, there might be some simplifying you could do. Notice in this case, the first term would be 1 here for the cosine of 2n pi. The last, oh, excuse me, that's not 2 pi. Never mind, this last term has some non-zero pieces. So this would be the only one that we could really simplify if we were interested in trying to write down a formula, an actual, honest to goodness, sum from n equals 1 to infinity formula for the Fourier series, which I'm not going to do here. I just want to get some terms down. Okay. All right. So now we've got our constant, we've got our coefficients on the cosine terms, and we've got our coefficients on the sine terms. We need to adjust a little bit. Remember, for the constant, I've got to divide by the period. For the cosine and the sine, we've got to divide by half the period. The period is 3 for this particular function, so we'll divide this constant by 3, and we'll divide these constants by 3 halves, or multiply by 2/3. So when we make our function, f of x, I want to do number 1 divided by 3. I want to do 2/3, because again that's dividing by 3 halves, times the sum of, I want to take number 2, and I want to multiply that times the cosine of 2 pi n x over 3, and I want to take plus number 3, and I want to multiply that by sine of 2 pi n x over 3. The variable here is n, and this is just generating some terms. We're going to start this at 1, because that's the first term that we get out of the cosine and the sine pieces. Remember, the constant's kind of the 0th term, and then we get individual terms for the first term, the second term, and so on. We're letting n equal to 1, and let's just go up to 15, because that gets us a good chunk of points, or excuse me, a good chunk of pieces to the function that we can see a graph of. So if I hit enter, we should get a graph. And I just realized that I made a mistake through this whole thing, because it actually plotted what I told it, or I actually found the Fourier series for what I told it to find the Fourier series for. But remember, this was supposed to be 2 here instead of 1. I goofed up. I apologize for that. This part was supposed to be a 2. So really what I plotted here, what I got a Fourier series for, was the function f of x equals 2x from 0 to 1, and f of x equals 1 from 1 to 3. So I made an error there, but if I wanted to change this to 2, I could do that pretty quickly here, I think. Let's just change this integral, this to a 2. I need to put in a 2 in front of this cosine here. And I need to put in a 2 in front of this sine here. And then I need to go back here to the sum, and I need to change a couple of things. I need to change this to a 5, because that's our new constant. I need to change that fraction. Let's see if I can get the whole fraction here. No. Need to delete the fraction here. It's making me do it piece by piece. Oh, come on. There we go. There we go. Now I get the whole fraction. I need to take a half of number 2, and then I need to take, I need to get behind it, I guess is the issue here. Here we go. Let's get to the other side of this. And let's see if I can delete this now successfully. I did. So now I need this to be number 3. And there. Well, no, I messed it up again. Okay. So what did, oh, there's an extra half in here for some reason. I don't know why. Let's see if I can get rid of this half here. Ooh, must be another extra half over here. Yep, let's get this out of here. There we go. Now we got it. All right, so I apologize for the little error there, but now we've got the Fourier series for what we need. If you follow what I did at the beginning of the video and get your correct function here at the second part, you should get the Fourier series that I showed here. So hopefully this at least gives you a little bit more instruction for how to start these ones with